I did ask you at the end of class to tell me about the other end. What happens at 1/3 for this power series? Yeah.
How are they plugging foundation negative squeeze at 1/3 out of minus and x would be 1/3 c and over 1/3 square root of 1/3 plus 1.
Oh, hang on, we're plugging in for x, so that still stays in n. But now that I have that, as we did in the previous one, what cancels? What can I simplify there? Tom? Aha, because the 3 to the n and the 3 will cancel, but the negative will stay behind. As a matter of fact, frequently you'll see people take any negative item raised to a power and split it into the negative power and then the number to the power. So quite frequently, I might write that negative 3 to the n as minus 1 to the n, 3 to the n. And then it's a little more obvious that the 3 to the n and the 1/3 to the n cancel. So now I need to know what to do with that. Does this converge or diverge? Yeah.
Maybe negative and 1 over n, the negative sign out, maybe it's 1 over n.
But I can only do the comparison tests on series that are all positive. So I could try and do absolute convergence here, right? But if I do that, then the thing I compare to is this, and we know that diverges. So I actually think that won't help me, because knowing that it compares to something that diverges in absolute value doesn't tell me about conditional convergence. And I need to do something else for that part. So let me see if I can test it directly instead, without getting rid of that minus sign. If I do that, Tom? It's an alternating series with the minus signs in there. So, alternating series test requires two things. I'll call Bn the absolute value of An, so that's 1 over root n plus 1. So I do need that term separately anyway, Leo. And now I need to know what happens to that. I need to know what's the limit as n goes to infinity of this. Great. And is it decreasing? And in this case, I can tell directly when you make the denominator of a fraction bigger, you make the whole fraction smaller, so it is decreasing. And what does that tell me about the particular series we have here? If both of those are true, the alternating series test tells me it converges. And that means that in spite of the fact that negative 1/3 is not part of our interval of convergence, positive 1/3 is. And not really about the edge cases, but there are places where the edge cases are the important ones. In particular, in both physics and engineering and electrical applications, and thus in medical and chemical applications, we end up with functions that are hard to express as anything other than power series. And it's the edge cases right at the limit of the radius of convergence that are where the more interesting stuff happens chemically, biologically, physically, etc. The differential equations course covers this in a lot more detail. We'll talk about that a little after this chapter, but we won't get to the series stuff until much later. So now we've finished the problem I wanted to finish yesterday, but I did want to point out to you that I did add another problem to our Canvas page. Back when I was learning voiceovers and VoiceThread, I made a VoiceThread movie solving that problem. That movie is available right here in the handouts section of our Canvas page titled Power Series Movie, and it'll screenshot you through the calculations as I narrate over it. So if you want to hear another one, presto. But this is question and answer day. So 11.6, 11.7, 11.8. Ratio and root tests, general series strategy, and power series. What questions do you have? Pretty sure that wasn't me. 11.8.24. Hold that. Ooh, textbook. Okay. How about we look at either 27 or 28 as a comparator? How about 27? It's a very similar style of problem. Okay. 27. Asked me to look at, oh boy, the sum x to the n over 1 times 3 times 5 times 7 up to 2s1. The product of odd numbers only. So this isn't quite a factorial, because factorials would take all the numbers. This throws out all the even ones. But it's really kind of close to a factorial. Because, Leo, we're still multiplying in the same way, aren't we? So I think, because it's kind of like a factorial, I'm going to approach this like the ratio test, which is the best thing to do for power series A. Okay. This is the expression for AN. So that's the thing that goes on the bottom. What's the thing that goes on the top? Yes, I have to replace this n with an n plus 1, but also I want to note, I can't figure out what I'm reflecting off of. I also want to note that the one right before that is 2n minus 1. Right, so that's for this one. But before I do that, before I deal with what's going on here, I'm going to flip and cancel as much as I can. So when I do that, The reason I pointed out that the previous term before the 2n plus 1 minus 1 term is 2n minus 1 is it shows me that everything in the top here all the way on the right cancels with almost everything on the bottom. And the only thing that survives on the bottom here is this one term. Everything else cancels out. And now, Leo, I will do what you suggest, and I'll write that as 2n plus 2 minus 1. So that's 2n plus 1. And then on top, I'm left with a single x. Oh, it's an absolute value. Yes, because remember, I want the L to be less than 1 in absolute value when I do the radius and interval of convergence. Well, what's that limit?
That'd be like x over c. X over infinity is going to be just x.
X over something huge
0.
is 0. And you're right at that point, Madison, now I can say, really the absolute value didn't matter because this went to 0. But if this had gone to any expression that had still an x in it, I'd need at least that part to be an absolute value. But this is always less than 1. So the radius of convergence is infinity, and the interval of convergence goes from minus infinity to infinity. This converges for all real numbers. That only works when the result of your ratio test is 0. Is on type.
Does that change automatically to n or automatically to
X.
x?
Because n is the index of my series, and so it changes as I add up a thing, but now it's which x's make this something that converges, and the answer is any of them. Leo, we just said something, x over something huge, really x over infinity is 0, right? So in a sense, we can kind of think of like infinity and 0 as reciprocals of each other. You know, you divide by 2, you get 1/2. You divide by 7, you get 1/7. You divide by 1/2, you get 2. You divide by something really small, you get something really huge. So if you divide by 0, you get infinity. That's really very sloppy and requires some more precision, but it works for the moment. Because then what I can say is that this radius of convergence comes directly from the number we get out of here. Jacob, when you were talking to me yesterday about this one, we had that number 3 right there, right? Well, then my radius is 1 over that, isn't it? My number here is 0. My radius is 1 over 0. It kind of works. Two mathematicians by the name of Cauchy and Hadamard put this together in a result from the 1800s, which is a different version of the root test. There are lots and lots and lots of other tests that we're not going to cover because they only work in very edge cases again, and I didn't think they were worthwhile. Cauchy Hadamard comes up in a different course, but I thought I would mention the idea of this reciprocal notation. More questions? Ask me more things. Yes, Jack.
11.7, I'm just kind of confused on,
That's the whole point of 11.7 is to try and go through our list and figure out which test to use in each given case, right? So let me pull a random problem. How about number, I don't know, 13 or number 15? Just pull something out of thin air.
we do, yeah, we do 13.
Okay, so 13 says 3 to the n times n squared over n factorial. And that goes from 1 to infinity. So I'm going to try and keep that flow chart and list in my head. I start right at the beginning. Does this look like a geometric series? Because that would have n to add to the power, or n minus 1. Does it look like a p-series? That's easy. Since it doesn't look exactly like them, or even kind of like them, I'm pretty sure I don't want to do a comparison test. I would need to compare to a p-series or a geometric series. So I move down in ideas. It's not alternating, so I think I'm going to throw out the alternating series test. Okay. Is there any chance this just diverges with the test for divergence? My first reaction is, I don't think so because of the factorial on the bottom. Factorials get really freaking huge really, really quickly. I'm pretty sure the limit as we go off to infinity is going to be 0. Even if it takes a bunch of flipping all work to get there. I'm pretty sure I can't show the limit is something else, so I'm not going to try the test for divergence. But I just said the word factorial. My brain says as soon as I hear that word, I should start thinking either the ratio test or something like that. So let's try the ratio test here. But you see how I went through that process of elimination? That's the whole goal of 11.7. Here's a series, what should I do? How do I walk through the decision tree of options in front of me? By the way, the ratio test will work perfectly here. Let me just write up another series, and rather than actually do the test, let me just figure out which test I should do. Number 19. Looks like this. And my first reaction is, man, that's nasty looking. Now, the question actually simply says, test for convergence or divergence, right? So I don't necessarily need to know if it converges absolutely according to the problem. In that case, what kind of series is this? So let's just start there. Let's try the alternating series test to begin with. But I can only do that, Jack, because you recognized it as an alternating series to start. So now I need to remember, okay, what's the alternating series test? There are two conditions for that. Let's see if they work. Make sense? In a very real sense, this is the same idea as back in chapter 7. I think it was chapter 7, section 5, where we talked about the strategies for all the different integrals. We said, oh, well, let's start with, can I do a U sub? Can I do maybe a slightly more complicated U sub? Can I do partial fractions? Can I do a trig sub? Is this a trig form integral? Are there some nice identities I can do? Or do I have to try and pull out something crazy for the sake of it? Can I do a P series? Can I do a geometric? Is it alternating? Is it a comparison to one of those known types? That sort of manner of method of elimination. Most of the series we do, matter of fact, almost all of them, I just rip out the root test or the ratio test. Here, we're going to do this. Wham! Sledgehammer and kill the fly. Well, I can do the ratio test on both of these. It work. I'm pretty sure doing the ratio test on that bottom one might actually give me 1 as an answer. So while it works, it isn't helpful in that case. Better? Yeah. All right. More questions? Do you actually want to see me finish out either of these? I must tell you that I have a hard time writing a ratio test because I keep writing ration instead of ratio. And I don't know why. I think it's because the spacebar and the N are so close together that I hit them by mistake. And autocorrect doesn't catch it because ration is a real word. Yes, ma'am. Yes. Yes, absolutely. The thing to remember about a factorial is that there are two ways to think of n factorial. It's all the numbers starting at n multiplying down until I get to 1. But in that case, I can also think of it as being built up. Right? So each factorial comes from adding one more number to the previous one. But if I generalize this pattern, then 3 factorial can also be written as 3 times 2 factorial. And 4 factorial can be written as 4 times 3 factorial. And n factorial can be written as n times n minus 1 factorial. Wait a minute, that means that n plus 1 factorial is n plus 1 times n factorial. And that's where I start to see canceling occur. And n plus 2 factorial is n plus 2 times n plus 1 factorial, or I could write n plus 2 times n plus 1 times n factorial. I can write out a bunch of the beginning terms, and then everything from some point down is another factorial. So if I see something like that, which was in one of our problems at some point. The next one is going to be this, right? But that's the same as 2n plus 2 factorial. Let's peel off the first two terms. Why 2? Because there's a plus 2 there. So I'll write this just like I did up here as this one, the next one down, and then the factorial for the rest of them. Now, if I was doing the ratio test, those pieces would cancel, wouldn't they? That's my best trick with factorials. You're very welcome. Another sneaky calculus idea. If you think about the factorials, one of the questions we could ask is, like with the integral test. In the integral test, we said, is there a function that goes through all of those dots? So is there a function, f of x, where on every integer we get n factorial? And it's very hard to find such a function. It's not easy at all. But there is a recurrence to the way we define the factorials right here, right? So what if I defined a function f of x like that? Well, that's a method called analytic continuation. And it's based off of power series. So you actually define this function that matches the factorials using a series. And it's called the gamma function. That's a capital gamma, not a lowercase gamma. But once you do that, then you could figure out what gamma of 1/2 is, or what gamma of 1/3 is. And then the idea of doing 1/2 factorial actually works. Okay, here's the fun part. I sent you all that note about the lecture that's going to involve this $1 million prize problem with the Riemann function. The Riemann zeta function uses gamma rays. So understanding factorials and understanding this idea of making factorials a bigger idea works and might be worth $1 million. I also mentioned at one point that 0 factorial was equal to something. 0 factorial is equal to 1. That doesn't come up a lot in this course unless we see it like an n factorial with a series that starts at 0, and then every time you say, well, what's 0 factorial? There's a great story about why 0 factorial is 1. Because you can also think of factorials as arrangements. There are 7 of you. I'm going to line you up front here. How many different ways can I do it? I mean, is this, is there only a couple of choices, or are there thousands of choices? How many different ways could I line up the 7 of you? I'm sorry? 7 factorial. Because how many choices are there to fill in that first option? There are 7 choices here and 6 choices here because I can't put the same person in 2 spots, and 5 and 4 and 3 and 2 and 1. That's a big number. That's not a small. 5,040, I think. It's a big number. I would like to present you with all of the arrangements, all of the ways to line up my Olympic gold medals. It's an empty arrangement. But it's still an arrangement, isn't it? So lining up 0 things happens one. But you can also get this from the gamma function extension idea. So they're connected, I promise. I'm not just wandering all over the place. Back on track. More series questions. Yes.
11, 8, 26.
26. The big problem in this is the logarithm, right?
Yes.
So let's take a look at 22, because that also has a logarithm in it. Will that work? Okay. Guess I'll tell you. In 22, I have b to the x over ln of n b to the n over log n x minus a to the n goes from 2 to infinity, and all we're told is that b is bigger than 0. Why does this series start at 2?
One would be 0.
Can't divide by 0. Okay. Well, we're asking about radius and interval of convergence. Let's do the ratio test. In spite of the fact that there are no factorials in this problem, I think the ratio test is almost always easier than the root test. So I'm only going to do the root test if everything has a power on it and that logarithm term doesn't. That is not a small term to write out. Hey, Leo, what happens when I start canceling? Right. So when I do that, I'll end up with b to the n plus 1, ln of n plus 1. The x minus a to the n plus 1 is on top. This gets flipped. This stays on the bottom, x minus a to the n. And then I have an ln of n and a b to the n, because I take that out of the bottom and flip it over. All inside absolute values. Clearly, I'm using canceling here. But what I can't cancel involves the logarithms. I'll get 1 left over b on top. I'll get 1 left over x minus a on top. But I will have ln of n over ln of n plus 1. Now, since b is positive, we were told that right here, and n is getting big, the logarithm terms are positive. The only thing that needs the absolute value is the x minus a part. So what do I do with this? Unfortunately, I cannot cancel within the ln. But what happens just to ln of n as n goes off to infinity? Because the graph of the logarithm looks like that. Wait a minute, that means that the bottom is also infinity, yes? Look, L'Hopital's rule to the rescue. That's infinity over infinity. What's the derivative of ln of x? 1 over n, then for the top. Well, wait a minute. That's a fraction within a fraction. Rip it and flip it again. And I get limit as n goes to infinity, n plus 1 over n. And that limit is, say again, 1. Okay, wait a second. I want my limit L to be less than 1 for absolute convergence. There's my radius of convergence right there, 1 over b. Does it ask me for the actual interval of convergence in this problem? Yeah, so I would have to check the edges. If I put in 1 over b, then this is going to be a 1 over b to the n way back at the beginning. And those will cancel. If I put in minus 1 over b, then this will be a negative 1 to the n, and I can use the alternating series test. So I'll have to check the edges separately from the rest of this, but now at least I know the radius of convergence. And Leo, I think that's going to show up for us in a lot of logarithm problems. Whenever I have a logarithm, I'm probably going to need L'Hopital's rule to deal with it. Does that make sense?
Yeah.
Wonderful. More questions? Yes, Norm. What can I do that's similar to that one? 22 is similar to that one. Yes? So let's take a look at 22. Okay. What do I know about sine K? That's all sorts of messed up, isn't it? Which means if I add 2, I know that, right? Which means I can take the reciprocal, 1 over. And if I put 1 over, I'm going to reverse all of those inequalities, aren't I? Wait a second here. One over this thing is always bigger than 1/3. That means the limit as k goes off to infinity can't be 0. It's bounded below. If the limit isn't 0, then this must diverge. I think you will find in the problem that you asked me about that this sort of replacing of a trig function with a number, because it's bounded by numbers, is the best way to proceed. More questions? You're still looking at me like you're not happy about that. Figure out. Right, but the only difference is the cosine squared, right? Start at the very beginning. -1 less than or equal to cosine less than or equal to 1. Square it. Multiply by n. Add n. See what happens. Now, in our case, we were comparing with a constant. In that case, you'll be comparing with stuff with n's in it, right? I have an idea. Pretty sure there's a comparison there then. I got lucky and could compare to a number. You're going to compare to a series. And that leads me right to, hey, there's a direct comparison because I built a chain of inequalities. More questions? 11,622. The problem is there isn't a nice formula, is there? So let's look at the individual terms and see if we can figure out a pattern. What's the next one going to be? Wait a second. I want to think about this like the factorials. Each one is the previous one times something else. Yes? What can you tell me about the numbers that are outside the box? The fraction. Say again? Having 3 on the top and 2 on the bottom, which means if I just looked at that fraction alone, it's bigger than 1. What happens to each term then? Because my goal is to compare them, right? If it gets bigger, its limit is not 0. I'm in the same boat as I was right here, aren't I? Oh, because I didn't have a formula, I had to do that investigation. There is a way to write a formula for this, but it sucks. But since my ratio test would actually have me test each one after the other, I know that everything cancels except those last 2 numbers, the one on top and the one on bottom. And that is bigger than. So you can actually write this out with the ratio test, as well as the test for divergence. If you have more questions for me, you should come see me in office hours this afternoon, or you should email them to me over the weekend, and I will get back to you, and I will see you all on Monday when this is all due. And then we will start looking at functions based on series. That's where I have an interesting research project. It's on the wall on the poster in first floor Lynch. Go take a look. I'll see you all on Monday.